So let me emphasize that why we needed to spend time on this on geometry and the probability, because this is a part of the material required for middle school students, but I don't think they are heavily covered in the schools. So so if we look at the math computation problems, and they are always there, so that means required, but does not mean the school will, the teachers in school, public school will teach you this type of mathematics. Okay, so I hope, okay, use this opportunity to learn the basic geometry and the probability. Okay, so today I'm going to talk about coordinate geometry. The so-called coordinate geometry just use algebra to study geometry problems. Okay, after that we're going to focus on geometry, plane geometry without coordinate system. Okay, so in a plane you have two perpendicular axes. One is called the x-axis, other one called the y-axis. Okay, then every point in the plane, it's one-to-one corresponds to pairs of numbers. Those called the coordinates of point P. So how do we, if our point is here, how do we determine the coordinates of point P, right? And you draw the vertical line, and this is x-axis, this is y-axis. So those are two coordinate lines. So then this point has coordinate A, then draw horizontal lines. You get the intersection point with the y-axis, and this intersection point has coordinate B on the y-axis. Then those two numbers, okay, uniquely determine the location of the point P. So this is okay, and those two numbers are called the coordinates of the point P in the plane with the coordinate system. Okay, so now then you can use the algebra to study the geometry problems. Okay, so let's work on the following problem. Suppose you are given a triangle, and the triangle has 3 vertices, right? So what you're told that are the coordinates of the 3 vertices, okay? And you want to find the area of the triangle. So let's draw let's plot those 3 points, and then you will get, here's 0, 0, right? And that will be and 4 and the 2, and that point is -2 and the 4. Okay, so you have 3 points, and you connect those 3 points, you get a triangle. Then you want to find the area. Remember the area formula, right, of the triangle, right, is going to be A equals half of the B times H. Okay, this is a formula we have, H and the B. However, the given triangle, you cannot easily find the base. You cannot easily find the height, right? And it is placed in this form. Okay, only one vertex is at the origin. So how do we solve this type of problems? Then you say, okay, I still want to use the area formula for the triangle, but you have to find one side is the edge length. Then you still have to find the height. It's extremely difficult, I tell you the truth. Okay. So we give up that. So what I can try is use a so-called subtraction method. Okay, we call the subtraction method. So first of all, you look at the trapezoid. Okay, the trapezoid you get. Okay, then you find the area of the trapezoid. Then you subtract the area of the 2 triangles. And those 2 triangles, it's easy to calculate. The areas is easy to calculate, right? So the trapezoid, so the area, use the subtract method, so the area is going to be the area trapezoid. And how do you find the area trapezoid? And that is going to be This side is the length is 2, the other side is the length is 4. It's a 4 plus 2, right? The average value times the height, and from here to here it's a 6, so times 6. And then it's going to be 3 times 6, it's 18. So that's the area of the trapezoid. Then you subtract, yeah, this is the area of the trapezoid, okay? Then the area of the triangle, the first triangle, is going to be half of, right? Half of the one on the left hand side is 2 times 4, so that's a 4. Another one is going to be it's the same, like it's 2 times, yeah, also 4, so it's also 4. Okay, so the area of the triangle is going to be the difference, right? Subtract 4, another 4 from 18, and then that's going to be 10. Okay, so this is how do we find the area. Okay, use the subtraction method. All right, so you got the idea, right? So it's easy to find the area of the right triangle, but it's not easier to find the area of some a different shape, another shape. Okay. So we use the algebra, to solve geometric problem. If you know the coordinates of the triangle, and you can find the area of the triangle using the subtraction method. All right, so you get some ideas, and I hope. Where's my next problem? Yeah, it's here. Before I talk about next problem, remember the area formula. There are several area formulas there. Okay, one is the base times height divided by 2. But if you really know the 3 sides of the triangle, it's A and the B and the C. Okay, so if you know the 3 sides, you can find the area using the following formula. And we're going to talk about this later. So S is half of the parameter. Okay, so that's one of the formula. Okay, and then once the 3 coordinates are given, the 3 coordinates the coordinates of vertex are given, vertices are given, then you can figure out the length of each side, and you still can use this formula to find the area. But that takes too much time. So the shortest cut is to use the subtraction method to find the area. Okay. All right. So our next problem, I want you to figure it out by yourself. So you have the triangle with the vertices. Okay, this point is going to be 4 and -2, and that point is 1 and 3, and that point is -2 and 1. So you have those 3 points. Okay, and you get a triangle. Can you find the area of this triangle using the subtraction method? Okay, how do you do that? Okay, the vertex is not at its origin, right? The vertex is not at its origin. The idea is similar. You probably, what are you going to do? I'm going to use the following method. Instead of using a trapezoid, I use a rectangle. Okay, that's my hint. Okay, this is a rectangle, right? This rectangle covers the whole triangle. So in order to find the areas of the triangle, you just need to find the areas of this rectangle and subtract the area of the 3 triangles, total area of this triangle. One is here, right? Another one is this one, and then this one, right? There's 3 triangles here. Okay, got it? Can you do this? All right, I see somebody else get the answer here. So let's see how many the edge lengths. The edge length of the triangle, right? So that is going to be from -2 to 4, it's actually 6. So from here to here, actually is 6. And from -2 to 3, that's actually is going to be 5. Okay, so the area, first of all, area is a rectangle, 5 times 6, right? And then you subtract the area of the 3 triangles. The first one, the lower left, it's half times 1, 2, 3 here. It's a 3 and a 6. Another one, up left, okay, 1/2, 2 times 3, okay, and then the upper right, half, and that is going to be 3 times 5. Okay, so then you simplify it. So I'm going to get 30. It's minus, I think, -9, -3, and this is a fraction. Okay, 15/2. Okay. All right. So after you simplify it, 30 minus 12, right? 30 minus 12, it's going to be 18. Right? So it's 36. Finally, it's going to be 21/2. Okay. So that is answer. Okay, 21/2. Okay, just use subtraction. Okay, got it? Yeah. You can use a trapezoid to cover it. You can use a rectangle to cover the triangle. All right. So that's a so our next problem is about how to find the distance between two given points. Since every point you can use a pair of numbers to describe the location, right? So after you enter all the information of the point, right, can you quickly calculate the distance between 2 points, right? So to do that, you need a Pythagorean theory, okay? So we have 2 points, P1 and P2, and that's going to be x2 minus 2, and here x1 minus x1 y1. Okay. So so you draw the right triangle, okay, and you assume that P1 is below P2 and on the left hand side. Okay, just make it simple. Then you will see this is x1, that's x2, right? So the difference between x1 and x2 gives you a length of one leg of this right triangle, which is x2 minus x1. And then the difference between the y coordinates of these 2 points gives you the length of the other leg of the right triangle. So y2 minus y1, right? Y, this is a y2, right? And here's a y1. So the difference of those two numbers gives you the length of the other side. So by the Pythagorean theory, if the distance between P1 and P2, then d square is going to be x2 minus x1 square, y2 minus y1 square, right? So from here, you can solve for d. So that is called the distance formula. Okay, right? That's just Pythagorean theory. Okay. So now you know how to find the distance between 2 points. Okay. The simple example is okay, what is the distance between the 2 points? If here, if in this case, if P1, okay, I give you coordinates, and let's see, 1, 2, 3, 4, and -4 and -1, and P2, and here is going to be 1, P2, it's a 3 and a 3, right? So P2 has coordinates 3 and 3, and the distance between P1 and the P2 is going to be the square root of the difference of the two coordinates. So 3 minus -4, okay, square, and the 3 minus -1 square. The difference is their y coordinates and the difference in x coordinates. Okay, so the difference of those two numbers and the difference of those two numbers. So you can use algebra to solve this geometric problem. So be careful when you use when you take the difference. Okay, so this is going to be 7, and here is going to be 4. Okay, 4 square. Okay, so that is going to be 49 plus 16. After simplifying, that's a 5, and I think 65. The square of 65 is not is slightly above 8, but it is an irrational number. Okay, you cannot simplify it. It's an irrational number. Okay. Yeah. All right. So let's take a look at the next problem. A triangle has vertices of coordinates 1, -1, 3, and 4, 4 and 3, and the 5, -1. What is the length of the longest side of the triangle? You take a look at this triangle. Which one is the longest? Yeah, which side is longest? Which side is the longest? Right. I think you can make a simple observation. Okay. And I'm pretty sure this one, let's label it. Okay, it's A, B, and the C. And the B is going to be 4 and 3, I'm pretty sure. Yeah, 4 and 3. Okay, C is going to be 5, -1. A is going to be 1, -1. Okay, and yeah, right. If you draw the picture correctly, then you can quickly see that, okay, the distance between A and B is the longest one, okay, between A and B. Okay, so you can do the, you can quick, yeah, the distance between A and B is a square root of the difference of the x coordinates, the difference of the y coordinates. Okay, so it's going to be 3 square plus 4 square, which is 5. Okay, and you can also check the distance between B and C, and that is the difference between, yeah, it's a 5 minus 4 plus -1 minus 3 square. Okay, and you will see it's going to be 1 plus 4 square. Okay, 1 plus 4 square. Yeah. 1 plus 4 square, 16, so square of 17. This is a definite less than 5. Okay, and then you don't need the distance formula, just between A and the C, it's horizontal line. So the difference is 5 minus 1, which is going to be 4. Okay, and clearly, the distance between A and B, okay, is the largest. It's the largest value. Okay, yeah. All right. So now let's move on to next problem. Okay. So you are given a square. You are told that it's a square, consists of these 4 vertices. Can you find the area of a square? Now you are told already it's a square. You can verify that, but it's not necessary to do that. Make a simple observation whether it's a square or not. I wanted to try, and if you get answers and post to me, don't post to everybody. You just click my name in the chat window and post it, so I can see your answer. Right. So you don't be, if you don't feel embarrassed if your answer is wrong, right? I think we needed to label them, to find out what is yeah. Okay, like here should be this should be 1 and 14. And that one is where's -4 and 2, -4 and 2. And now should be equal to 8, -3, and that should be 13 and 9. Okay. All right. So if the edge length of this square is d, then the area is going to be d squared. So you're told that's a square, so you don't need to verify that. All you have to do is just find the d. Then you can use any pair of the numbers to find the d, right? D squared, right? So d square is going to be, is going to be the difference of the x coordinates, 13 minus 1 square, and the 9 minus 14 square. Okay, so it's been 12 square plus 5 square, and we know it's going to be 13 square. Okay, which is 169. Okay, so that is the answer. Very simple. Yeah, of course, it's possible it's not going to be. It's possible it's not a. If it's not, you can find out all the 3-4 sides, and you can say that, okay, based on my calculations, it's not going to be the square. That's possible. But if you're told it's square, you just needed to use any pair of the nearby, points. Okay, if you just you have to figure out which pair of the points are on the same side. Okay, it's not on the opposite side. If it's opposite, then you get the length of the diagonal. Okay. Okay. Now we're going to focus on lines and the linear equations. Okay. So how do we describe a line in the space? Okay, in the XY plane. So suppose you give a line, and we find out. Yeah, you take an arbitrary point has coordinates x1, y1. Arbitrary point has coordinates x2, y2. So then you have a triangle. Okay. This is a right triangle. Okay. Now this side is y2 minus y1. This side is x2 minus x1, right? Why is this x2 minus 1? Because here is the x2 and that is x1. So the difference gives the length of this leg of the right triangle. All right. But we find out all those triangles are similar. That means y2 minus y1 over x2 minus x1. This is a really independent, the location of the points. So if we have another point, if I have another triangle, a bigger, this is a P1 prime, X1 prime, Y1 prime, and here's a P2 prime, X2, Y2 prime. Then we find out those two triangles are similar. So their ratio remains unchanged. Okay, why this is true? You can also, this is the same as x2 prime minus x1 prime over x2 minus x1. Okay, this is about similarity of two triangles. Okay, we're going to talk about similarity of two triangles. Okay, so this smaller triangle is similar to the larger triangle. So the ratio of their corresponding sides, okay, they should be equal. Okay, so x, here's x2 prime minus x1 prime. So over the, this two triangle, you compare, this is triangle, one of the triangle, right? Another triangle is going to be larger. Okay, so this is a triangle. These two triangles, these two triangles are similar. So therefore, the ratio of the corresponding sides are equal. So from the second equation, you can get the first equation. Okay, So that means the ratio of the difference of y coordinates to the difference of x coordinates is going to be a constant. That constant is an invariant of the lines. That's constant. Okay, that is constant. Okay, this is a constant. Let's denote by it. So this is called the slope. Okay, it's constant. The slope of the line. Right. So I explained to you, it doesn't matter where you choose a pair of the points on the line. So this ratio, the difference of the y coordinates over the difference of x coordinates, it's an invariant. It's independent location of those points, and that is called a slope. Okay. So when you have a slope, when you have a slope, when you have a slope, and then when you have a slope, and you can describe the points on the line. Okay, you can describe the points on the line. So I'm going to denote the slope by m. Okay. Okay, so I'm going to get and put this way. So you have a strict line. This is an arbitrary point P, X, and Y, and this is a point you choose, and here's a Y minus Y1. This is X minus X1, right? So the ratio, I told you, it's going to be independent of the location of the point P and even P1. So we fix P1, then let's P change. That's going to be the slope. Okay, the slope. Okay, but how do you calculate slope? You can choose another point, right? Pick up 2 points on the line, you calculate the ratio, and you get a slope. Then you fix P1 and pick up arbitrary point on the line, and you consider the same ratio, and that should be called a slope. So, and you rewrite this relationship, and you get an identity we call the equation, which describe all the points, the coordinates of the points on this line. And this is a linear equation because there's no x squared there. Okay. And if you rewrite it, you can also multiply this out, like mx minus mx1. And I move this to the right-hand side. So I get mx plus y1 minus mx1. And this is a number, right? So y equals mx plus b. And this is called the slope intersective form. That's 2 forms here. Okay, slope interceptor form. Okay, and the y is the interceptor form because when x equals 0, y equals b. So this is a point on the line, and if you look at the picture here, that's actually this is a b. Okay, so that's why I call the y-intercept. B is the y-intercept. Okay, this is about the equation which describe the coordinates of point on the line. And if you know the y-intercept, if you know the slope, you can get the equation. Now let's do some problem. Okay, we can let's solve some problems. We can solve. Yeah, we can understand this better. Okay, so what is slope of the line containing 2 points? Okay, so let's draw the picture. Let's draw the picture. Okay, 1 and 2 is here. -1 and 4 is here. So this is a strict line. Okay, it doesn't matter which one is first. And maybe this one is the second, that's one is the first. Okay, so you have 2 points, and the line passing through those 2 points. Now, how do you find the slope? Okay, be careful, the order is very important, right? the slope M is going to be, write down the formula, y2 minus y1 is the difference of y coordinate of the difference of x coordinate. Okay, and so what is the difference, right? So y2 minus y1, so y2 is 4, y1 is 2, okay? And x2, which is -1, be careful, yeah, which one is x2, right? If y2 is 4, then x2 should be -1. So minus x1. So I get 2, -2, I get a -1. So that is the slope. And then it doesn't matter which pair of the points you choose. If you're given 3 points on the line, you can use any pair of the points to calculate the slope. Okay, so slope is a number unique to the line. Yes. Now, yeah, be careful which one is on the top. Okay, which one is on top? It's the difference of y coordinates on the top. Okay, it's the difference of x coordinates at the bottom. Even the answer is same answer, but maybe the formula is wrong. Okay. So let's try to solve next problem. So if the line has a slope of m equals -2 and the passing through the point, find this equation of the line in the slope point form and the slope interceptor form. Okay, we're going to express in 2 different forms. Right, so let me draw the picture. Okay, here's P and the 2 and the 1. That's the point of P, 2 and the 1. I think the slope is -2, looks like that. Okay, it doesn't matter. You know, I just sketch like that. All right. So here's an arbitrary point. It's coordinate x and y, right? If we forgot the formula, slope point formula, you can derive it directly by yourself. Okay. So the difference between the y coordinates, y minus 1, and the difference over the difference between x coordinate, that should be equal to slope. That's going to be -2, right? Okay, that's going to be -2. So immediately you will get y minus 1 equals -2 times x minus 2. So this is a slope point form, right? So you solve this, right? So this, okay, so if a point on the line, that means x and y, that coordinates, must be related by this equation. Okay. All right, so now you rewrite this. You multiply this out, y minus 1 equals -2, plus -2 times -2 is 4, okay? So y equals -2x plus 4 plus 1 is 5. So this is a slope interceptor form. Here's a slope point form. Okay. And now why it's interceptor form? Because if you get this equation and you see that when x equals 0, y is going to be -2 times 0 plus 5, which is 5. So 0 and the 5 is the y-intercept, we call it. Okay, it's somewhere here, 0 and the 5. Okay, so 5 is going to be y, yeah, is a 0, a y-intercept point. Okay, right? All right. So we pretty understand right now it's a relation. Yeah, given line, you can get an equation. And sometimes we have to solve the inverse problem, given a linear equation, and trying to sketch the line. Right? All right, so take a look at this. So now this time we are given a line, and we're trying to find the slope and sketch the graph if possible. So remember we have how to find the slope quickly. There are a couple ways to do. One is you find the 2 points on the line and use a formula to find the slope, right? Or you just use the equation. You can find the slope directly. Remember, every equation, if you write the equation in this form, this is going to be the slope. This is going to be the y-intercept. Right? So if you rewrite this equation and you express the equation in this form, and the coefficient of x is going to be the slope. Right? So you don't need to find the 2 points on the line, and then you determine the slope. Right? So let's write the equation. For y equals negative 2x minus 5. So y equals 2/4 is 1/2 and 5/4. Okay, so clearly the slope m equals negative 1/2. Right? Yeah, m equals negative 1/2. Now you can also you can find, yeah, based on this information, it's a little bit difficult to find the yeah, it's a little bit difficult to find to sketch this graph. To sketch this graph, you need the best way to do is to find the 2 points. Okay, I'm not going to use a y-intercept to find the one of the points. Okay, you can always, how do you find those 2 points, right? You can let x to be 0, you get the y coordinate, you can let x to be 1, you get another coordinate. So that then you plot those 2 points, then you sketch the line passing through those 2 points, because 2 points uniquely determine a line, right? All right, but here we just want to find slope, that's it. Okay. Now, before we solve this problem, we call talking about parallel lines. Okay, so first of all, 2 lines are parallel. Okay, how do you determine 2 lines are parallel? Okay, so you have 2 lines. Okay, this is a line, here's another line. Okay, so it's a slope is m1, that's slope m2, those are slopes. So the very important factor here is parallel if only if m1 equals m2. You know why? You know why? The slope, you see, is a ratio of those 2 points, those 2 sides, right? So if these 2 lines are parallel, then you can get exactly the same triangles. That's why their ratios are the same. Okay, so that's why they have the same slope. Right? If they're not parallel and then you draw 2 triangles, you cannot get 2 identical triangles. Okay, so it's easier to see if they're parallel and they must have the same slope. Okay. Right, so that's the important fact. So using this fact, then you can solve this problem. So the line is parallel to the given line, and so you have to find the slope first. So 3y equals negative 2x plus 1. So y equals negative 2/3, x plus 1/3. So from here, you will get the slope of the given line. That's for the given line. Okay. Since 2 lines are parallel, so this new line also has the same slope. Now you also know that it's passing through the given point, -3 and 1. -3 and 1. Okay, this is -3 and 1. That's a point P. So if you know the slope, if you know the point, you can figure it out, right? So the y minus 1 equals -2/3, x minus -3. Okay. Okay. Then you can multiply, you can simplify. You get -2/3x, and This would be -2, I think. Then you move -1 to the right hand side, and you get equation y equals -2/3, x minus 1. Okay, so that's how do we solve this equation? Okay, you get you want to get a equation in the general form, doesn't matter which form. Okay, now in the general form, well, the general form you have to multiply it by 3, so 3y equals -2x minus 3, and you move 2x to the right hand side, and you move 3 to the, yeah, you can write it like that. This may be called a general form. There's no standard general form here, okay? So any of the form is okay. All right. Yeah. So two lines are parallel if only if they have the same slope. Okay, I already explained to you. Now, if two lines are perpendicular, what you can say? Two lines perpendicular, if this is this one has a slope m1, this is slope m2, and I explained to you why the product of those two should be equal to -1. The product of that slope should be equal to -1. Why this is true? Okay, so you can assume this is at the origin. Okay, so I'm going to show you why. Yeah, when the perpendicular, why this is true. Okay, let me give you this one. Okay, so this is a point A and B, right? So perpendicular means this. Okay, and the same triangle just rotate here. So the coordinates, this one will be, the first coordinate will be -b, the second coordinate will be A. Okay, so as long as you end this picture, you know, it's clear, right? M1 and M2. Let's find the M1 and M2. M1 is clearly is B minus 0 of A minus 0, so B of A, right? M2, the y coordinate is A, so x coordinate to be -b. Okay, it's -b over A, negative A over negative A over -b. Okay, so if you want to take a difference, right, then this is okay. This is going to be z minus 0 minus 0, so it's still A over -b. So M1 times M2 would be B over A times -A over B. So that's going to be -1. Okay, if it's that perpendicular. Okay, so that is a proof. If two lines perpendicular, then the product of the slope must be -1. And conversely is also true. Okay. So let's take accept this fact. Then you can solve the problem. Okay, so the given line has a slope 5y minus equals x minus 1. So y equals 1/5x minus 1/5. All right. Another line is ky equals -5x minus 2. So y equals -5 over kx minus 2 over k. So you have two lines right now. Each of them is written in the slope interceptor form. So you can get the slope 1/5. You can get another slope -5 over k. So that perpendicular means the product should be equal to -1. So M1 times M2 equals -1. Okay. I think K should be equal to 1, Rebecca. Okay. Right? K is going to be 1. Right. Yes, that must have an opposite sign, the two slopes. It's one is positive, other one must be negative. So from here, K is going to be 1. Okay, k is going to be 1. So they're perpendicular to each other. All right. Yeah. So there are two important facts for the one is how do you check two lines of parallel, and then how do you check two lines of perpendicular? Okay, two lines of perpendicular means the product that the product of the slopes must be -1. Okay. Okay, so let's take a look at the next problem. I hope you can. I want you to try. Okay, I stop here and I let you to try first. So first of all, a line containing this point, -5, -1, and 5, which is perpendicular to the given line, 3 plus x plus 3y equals 1. Now, what is the sum of the coordinates of y-intercept of this line? So let me draw the picture here. So the given line is going to be, so it's harder to draw. This is given line. I just sketch it, okay? USC, Y, the line must be like that, okay? So -1 and the 5 is somewhere here, -1 and the 5. So I'm going to find the, yeah, this is line perpendicular to that, right? And I needed to find the B. What is the B, basically? Okay, so that's my picture. Can you solve it? So step 1, you have to get an equation for the line perpendicular to the given one. Step 2, right? And then you rewrite the equation and you get the y-intercept. Right? So please work on that. Okay, I hope you figured out. I'll get 2 different answers. All right. So, okay, first of all, let's figure out the slope of the given line. 3y equals, right, -x plus 1. So y equals -1/3 x plus 1/3. So the slope of the first line is going to be -1/3. So the slope for this, this is the first line. The slope of the second line, it should be equal to 3 because the product must be equals -1. So you get a slope of the new line. Then the equation, you have a point, you have a slope, right? So that's the equation for the new line, okay? And so you rewrite this equation. It's going to be 3x plus 1, so it's plus 3. So y equals 3x plus 8. So the y-intercept is 8, not 0. Okay, so y-intercept is 8, right? Right? So this is the y-intercept. Why is this y-intercept? Because when x equals 0, y equals 8. That's a point on the y-axis. All right. All right, so let's try next problem. Now, next problem, it's harder to draw the picture because all the points except the first one, then it's not clear where it is, right? So 1 and a -4 is here, 1 and a -4. So P and a -1, where's the P -1? Well, we don't know. So somewhere here on this horizontal line, P and a -1, okay? And the P plus 1 and the 3. 1, this is -1. 1, 2, 3. This is another one. All the points here, okay? So they're on the same line. So if this is a P, the P plus 1. So this is on the same line. It looks like that. Okay, and here's a 3. This is a -1, right? So here's P plus 1 and the 3, and this is P and the 3. All right. So can we find the value of P? Wow. If Q and the 1 is also on the point, this is origin, right? And what is Q? Okay, so if Q, yeah, that's the second question. So we find the P first. All right. This is yeah, this is going to be sorry. The point of P is here. My God, I forget. I marked it wrong. Okay. This is x-axis. Okay, this is a point P and the -1. Okay, and this is a strict line. Yeah. Okay. I think first of all, you use those 2 points to find the slope. Okay, so using these 2 points to find the slope, the slope of this line is actually fixed. The slope is the difference of their coordinate, y coordinates, and over the difference of the x coordinate. The difference of the x coordinate is going to be 1. So that's what even, you know, even each of the coordinates depends on P, but the difference is going to be 1. So it's going to be 4. So you get slope of 4. Okay, then you can use any of the points to find the slope, because if you use these 2 points and the difference of the difference of their y coordinates of the difference of the x coordinate, right? P minus 1, -1 minus -4. That's going to be 4 minus 1 to 3, P minus 1. So from here, you find the P. Okay, so they're equal, right? So this should be equal. So how can I do that? P minus 1 is going to be 3/4. So P equals 1 plus 3/4 equals 7/4. You know why? Because these 2 must be equal. Okay, you just solve the equation. So P minus 1 equals, yeah, 3/P minus 1 equals 4. Right? Then you can find P. Now, how do you find the Q? If Q minus 1 is also on the point, then the Q is here, right? Q and the 1. If this is on the point, then you use the slope to find the Q, because the difference of that, you can use any of the points, right? But you still use these 2 points, okay? So the slope equals the difference of the y coordinate and over the difference of the x coordinate, okay? So that's going to be 5/Q minus 1, which is still, what is slope? Slope is 4, okay? And from here, you will get Q equals, yeah, after simple computation is 9/4, okay? So that's how do you get the slope value of Q. Okay. All right. So the key idea is to find the slope first using a pair of points, okay, which is each of them actually depends on P, but just because of, the difference of their x coordinates actually is a fixed number, which is 1. So you can find the slope. Then using that, you can find all the values P and Q. Okay. All right. So let's try the next problem. So this one probably is the last problem. I don't have time left. All right. So for 4 ordered pairs list, okay, are the solutions of same linear equations, and the one is not. Given gives the first coordinate of the point that is not. Okay. Well, just find the point which is not on the line. Okay, 3 of the points are on the same line, and one of the point is not on that line. Okay, so I try to find the slope of this pairs. Okay, so each pair of the points, -2 and the 7, 3, -3, and I find the slope of those 2 points. Okay, so I get slope, and that is going to be 7 minus -3 and 3 minus -2. Okay, that's -2. -2, it's going to be 10 over 5, which is 2. Okay, right? Let's see, -2 and +2. Okay, -7. Okay, -2, 7, and 3, -3. So the difference of that coordinate, and that is going to be 2. Okay, and then you look at, those 2 points. Okay, you can choose any of the pairs. So we don't, you try to figure it out, right? So use these 2 pairs so you find the slope, and then you use those 2 pairs, use those 2 points, and you find another slope. Okay, so it's going to be, you can 7 minus 1, -2. Yeah, I'm sorry. This is should be negative. So that was a small mistakes here in the computation. Okay, so let's see. The difference is the y coordinate, like the first one minus the second one. Then you have to be very careful. -1 and minus -3, so it's going to be -1. Negative. Okay, 7 minus -3, -2 minus -3. Okay, so that will be -5. It's -2. Okay, be careful here. So here the difference of the y coordinates, 7 minus 1, and the difference it's -1. Okay, so it's gonna be 6 over -3, which is -2. Okay. Okay, so then yeah, I'm done almost. Okay, so -2, 7, -1, 6. So slope is going to be the difference of the x coordinate, 7 minus 6, -2 minus -1, which is going to be 1 over -1. Okay. Right? 7 minus 6 minus -2 minus -1, so plus 1. Okay. So, and the slope of those 2 points, 7 minus 3, -2 minus 0. So it's going to be 4 minus 2, so -2. So clearly, that's 1 point is not on the line because this is a fixed point, right? And then they have another point, right? 3 and the -3, and the slope is -2. Then you have a right? Then so this pair of the points, those pairs, they have the same slope, except for this pair of the points. Okay, so -6, -1 and 6 is another point on the line. Okay, because this is a fixed point, and there's the same lines, you know, and this will be another point, and the 1, -1, the same slope, but that's what should be on the same. And then 0 and 3, you know, 0, 3 maybe here. I just sketched about it. Yeah? So this is a fixed point, -2 and 7. And so those 4 points on the same line must be on the same line. So -1 and 6 is not on the line. Okay, because the slope is -1. Okay, so that's it. And we will continue. I think the next lecture will be on the angles. Okay, it's not coordinate geometry. That's the quick review of a coordinate geometry. Okay, you are welcome to stay in the class.